Think-Aloud protocol has long been one of the most commonly used evaluation techniques for usability testers, and is also used by visualization researchers, both to evaluate tools and methods, as well as to investigate the formulation of insights. But Think-Aloud user studies are a costly, time-intensive process, which up until now are almost always run synchronously, either in lab or via video conferencing. In fact, in a survey of visualization papers we conducted, only 1 of 67 Think-Aloud studies were conducted asynchronously, meaning without a researcher present. In this paper, we make 2 primary contributions. The first is a technical contribution called CrowdAloud, a tool for conducting and analyzing asynchronous Think-Aloud studies. The second is an investigation of the feasibility of crowdsourced Think-Aloud studies. We conduct 2 separate user studies, one which compares crowdsourced Think-Aloud to in-lab Think-Aloud, and another comparing Think-Aloud responses to more traditional text responses. In those studies, we found that Think-Aloud is comparable to in-lab studies and produces more insights than text responses with a similar quality. This video, however, will focus on the first contribution, CrowdAloud. CrowdAloud is built on top of Revisit, an existing tool for conducting user studies, but one without any audio capabilities. Revisit utilizes a domain-specific language, or DSL, for defining tasks and study structure. CrowdAloud can be enabled in that DSL with 1 line of code, and which tasks should be recorded in the study can also be set in the DSL. Optionally, you can add a mic check task, which will stop participants until they have demonstrated they have a functioning microphone. After a study is complete, CrowdAloud can be used to conduct a qualitative analysis on the Think-Aloud data. CrowdAloud has 2 primary views, the replay view and the tagging and transcription view, which are intended to be used together. First, let's talk about the tagging and transcription view. Recorded audio from the study is automatically transcribed, and researchers can edit the transcription at will. Researchers can also create codes, each with their own name and color. After creating a codebook, each audio snippet can be assigned codes. Codes are specific to the logged-in user, allowing multiple users to independently code. The true strength of CrowdAloud comes when researchers utilize provenance data in their study. Using provenance, CrowdAloud can recreate the state of the original study, replaying the study similar to a video. The provenance data is synced with the audio data, so that researchers can always see the same stimulus that participants saw while listening to their comments and insights. Here is a real example from one of our crowdsourced participants.
Sorry, if we're going to select for here, so we're going to assume that anything below 50, and that's probably high, about 30, anything below 30. Yeah, so the vast majority of people who died here. There's a couple of people who've actually fallen into the first class section, but even still, vast majority of the people who died were ultimately third class passengers.
The replay view is also synced with the tagging view, even if they are in separate tabs, allowing researchers to use multiple monitors for analysis. To aid with analysis, we also have an overview table view. The table view includes basic information for each participant in a task, like time spent, interaction count, and word count. You can also view tags, which were assigned for this specific task. Additionally, researchers can search for specific tags, in this case find all participants who made a UI/UX comment, question, or suggestion. From here, we can jump directly to their task analysis to see what they said. We hope that our findings, as well as our tool, CrowdAloud, encourages the visualization community to conduct more crowdsourced Think-Aloud studies in the future.